Okay, so hello everyone. In this video, we'll be solving a question number 3499, which is maximize the active sections with a trade 1. It is marked medium. The question is a bit confusing to understand, but once we clearly understand what the question is about, we can move towards a special not provided. And after that, we can finally understand the approach, how we should think about this, and what is the use of giving a special note. Okay, so let's first understand the question, what the question is asking us, what the question is demanding from us, and then we will try to form a, what you can say, an approach for it. Okay, we are given a binary string as, okay, we are given a binary string as, so we need to perform operations on a string. 1 represents an active section and 0 represents inactive section. Okay, we need to perform at most one. At most one means either it can be 0 or 1 number of thread. In order to maximize the number of active sections, what are active sections? Active sections are nothing but 1. So we need to perform at most one thread over a particular condition in S such that the count of ones within that string is maximized. Okay, so what is the trade about? We need to convert a continuous block of 1 that is surrounded by zeros to all ones. Okay, so first the operation can be done on the continuous block of ones. Either it can be just a single one, two ones, three ones, but it should be a one. And second thing is it should be surrounded by zeros. Suppose this is a block of one, on then on the both sides, that is on its right and on its left, it should be surrounded by zeros. If this is a block of one, but on the one side it is not having any zeros, but the other side it is having zeros, so that block of 1 is not eligible. Okay, afterward convert a continuous block of zeros that is surrounded by ones to all ones. So after we have converted that block of ones which is surrounded by zeros to zeros, now we need to find another block of zeros which is surrounded by 1 from both sides, and we will convert that block to ones. Okay, we need to return the maximum number of active sections in S after making optimal trade. So we need to maximize the number of active sections is nothing but number of ones within S. Okay, this note will be understood later. Let's first take one example. Before that, let's first clarify and jot down everything. If you are on to a particular question and it is a bit confusing, try to write down all the things given. First, write all the things which are given in the question, so that when you are jotting down those points, it will be easier for you to get a hold over that question. And while you are jotting down, you will be able to form an approach, and as a result, that chain of thoughts will lead you to a better solution. Okay, so binary string, which is nothing but 0 and 1. Okay, 1 means active section and 0 means inactive section. What do we need is maximum active section and how at most one thread. Okay, so we are given a binary string 0 and 1, and 1 represents active section 0 represents inactive session. We need to maximize the active section by performing at most one thread. But what is the first step we need to do is convert block of 1 to 0, and then convert block of 0 to 1. It is as simple as that. But the main thing which restricts us is that the condition of surrounding. In this case, surrounding zeros, and in this case, surrounding ones. Okay, so let's first take an example so that we can get the clear idea that what should our approach, what the question is about, and how we should move with it. Suppose S is a string like 4 times zeros, 2 times 1, 3 times zeros, double twos, 0, and 1. Okay, so we have found it. First is we need to convert a block of ones to zeros. But first step that we should do is identify blocks. Okay, so we have three blocks over here. First block is this, second block is this, and even though this one is a single and is not within a group, it can be considered in a continuous block. Okay, so then second step is check if they are surrounded by zeros. So for this block over here, we can see that there are there is one zero on its left and there is another zero on its right. So this can be considered. For this block, there is a zero on its left and there is one zero on its right. So this can be considered. But for this block of ones, there is one zero on its left, but there is no zero on its right. So we cannot consider this for any further steps. Okay, we have identified blocks surrounded by zeros, and the final step of the first step is convert to 0. Let's do for each one. So for this block of zeros, what we have to do is convert this block. For this block of ones, we need to convert that block of ones to zeros. Before that, we have four zeros which will remain as it is, and this one will become, these double twos, double ones will become double zeros, and the remaining part, which is this one, will remain as it is. So we have done with this part as of now, and for this, it is this part, this part. So this first part will remain as it is, and this block of ones will be converted to 0, and the suffix part, which is 001, will also remain as it is. So hence this is one of the final strings which will be formed, and with that the first step of one thread is completed. And the next step, which is convert a continuous block of zeros which is surrounded by ones, and convert that block to ones. So the main factor of this question is this surrounding part, is this part surrounded by zeros and surrounded by one. If that was not the case, the blocks present at the edges or the corners of the string would also be a valid contenders for these operations. Okay, so first we'll find a continuous block of zeros. In this case, it is one is this, one is this. In this case, it is this, this. Okay, we have got the continuous blocks of zeros. Now our second step is to check if they are surrounded by ones. For this block, for this block, we have one on its right, but we do not have any one on its left. So we cannot consider this block of zeros because it is not surrounded by ones from both sides. For this, it is surrounded by one on its left and it is surrounded by one on its right. So this block can be considered here. For this block, we have ones on its right, but we do not have any one on its left. So at this point only, we decline or reject this block. But we have one more block of zero, which is to consider. For that, we have one on its right and one on its left. So this block is to be considered. Okay, so after we have found out the blocks which are surrounded by ones on both sides, our next step should be convert those to ones. So we are converting this block of zeros to ones. So the part before it will remain as it is. This part will be converted to 1 and the part preceding it shall also be remain as it is. Also be remaining as it is. Now for this, we are converting this block of zeros to 1. So the part before it will remain as it is. This much part will be replaced with ones. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, and one more one. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 6, 8, 10, 12, 14. So yeah, we have formed our two strings after this one operation. First what we have done is identify the blocks these are three blocks, and then check which are surrounded by zeros. These are this block and this block is surrounded by zeros. Then what we do is convert it to zero, that block to zero. So we have converted those two ones to zeros, and after that we are trying to find another set of blocks but of zero this time, and it should be continuous. So these two and these two are the contenders. Later we find out which are surrounded by ones, this, and then convert those ones to. I guess this is a so big string. I don't know. Okay, what we did was, I guess that was correct. Convert those to zero and 0, 0, 1, 2, 4, 6, 8, 10, 12, 14, 16. So why is it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14? I guess there is one mistake over here. 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay, so here is the, yes, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Now we will count the number of ones, which is nothing but 1, 2, 3, 4, 5. Number of active sections are 5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And in this case, this is 10. So this is the answer. But how do we do this? We cannot manually like change these and later find out what we should do. What I was thinking is, let's do one thing. One, 2, 3, 4. 1, 2, 3. I guess 4 plus 3 plus 2, 9. 9 plus 5, 14. Yeah, this is the correct. What we are doing is, first we are finding ones, a continuous pair of ones, a continuous pair of ones, and a continuous pair of ones. And then we are checking if there are blocks or a single zero on both the sides, both the sides. And then we, in this case, what was this case? We move to the left. Okay. Then what we did was take this entire block, because what we did was first we converted this block to zero, so it became like 0, 0, 0, 0, 0, 0, 0. So this block was like this. This is not looking proper, so let's make this better. So as a result, we received this, which is nothing but this. And later, what we did was convert that zeros. Oh, you can do it like this as well. Convert those zeros to ones. So that block became 1 1 1 1 1 1. So like we can think like first we get a block and then we check on left, then we check on right. We get a block, we check on left, check on right. We get a block, check on left, it is present. On right, it is not present. Okay, so we cancel this one. After finding that these two blocks these two blocks are eligible, what we should do is, as we are going to convert it to 0, as we are going it to convert it to 0, then it will become 0 0. Okay, so after converting these blocks of 1 1 to 0, we got it like this. Now later we were like, okay, if we were to convert these zeros, we need to check if there is on its left, there is on its right, if there is on its left, there is on its right. So we could have checked it over here also, right? After after we have converted this to this, one ones to zeros, zeros to ones. So what we did, likewise, if this one one was to be converted to zero, it would have formed 0 0 over here. And what we would have done is convert this entire convert this entire 0 to 1. But later but later we realized that here there is no one. Here comes the thing that treat as if it is augmented with 1 on both sides, forming t equals to 1 s plus 1. So we had to consider it like this. But the augmented ones do not contribute to final count. No worries. If suppose we would have considered that there was one over here, just think that this huge chunk of zeros would have been converted to 1. So as a result, our s would have become, let's 1 2 3 4 5 6 7 8 9, and this 1 1 and 0 0 1. So the number of ones would be 1 2 3 4 5 6 7 8 9 10 11 12. So that why this not once given is that we need to consider that 1 is present on both the edges. So if there was such a case where there was 0 on the starting and on the end, we could consider that block of zeros for transformation. Okay, so yeah, where were we? Huh. So what I was thinking is, if we are to deal with zeros and one only, and think of only how many are on its left, how many are on its right. Like there are 4 continuous 0. Then we have 2 continuous 1. Then we have 3 continuous 0. Then we have 2 continuous 1. And then we have 1 continuous 1. So we do that for this one, there are zeros on both sides because if it was on not on zeroth index, as we know that it is not on the starting, it means that there is one zero or a group of zeros before it. So we could have seen that first these two ones were converted to zeros. So our initial count of 1 would become -2. But later we realized, oh, these four zeros, these two zeros, what are these two zeros? Which are formed after conversion. And these three zeros, when converted to 1, 4 plus 2 plus 3, which will give us 4 plus 2, 6, 9, 9 ones. And the remaining 3 ones will give us, sorry, 4, 2, 3, 2, 6, 6 plus 5, 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay, yep. 4 plus 2, 6, 9. These 9 ones, when paired with 3 remaining ones, the answer will be 12. So here also our answer is 12. And here also we found out that, oh, after conversion, initially these were the deducted. These were removed from the initial count. But later we found out that when it was paired with its neighboring zeros, we got this number of ones once again. They were restored, but we got this number of as additional. So the ones were restored, but neighboring ze- zeros were also added. Just think like if we have considered this block of twos and it was converted to zeros, so we would have first of all lost two ones. And but when this zero, when this block of zero was reunited to form and convert to one, we would have first got these three zeros, which will be converted to ones, then the original, which were lost, that one, and the new zeros on its right. So we got additional zeros. Okay, that is on the left and that is on the right. So if string was, let's consider this one. Since there is nothing after it, since there is no block after it, this cannot be considered. Suppose, let's take one more example. 1 triple 0 1. So we can think like 1 1 followed by 3 zeros followed by 1 1. In this case, let's take this one. It is not possible because it is not having any block of zeros on its left. And for this, it is not having any block of zeros on its right. Here, let's do it quickly. 1 1 2 0 It is so big. Let's do keep it this much only. Okay, this one could not be considered. This one cannot be considered. So you can think like if a number starts from string starts from 1, the first pair is not considerable and the second pair is 0, so we do not count that. And if the last pair is 1, it is of no use because there is nothing on right here as well. If the last pair was 1, there is nothing on its right. So if s starts with 1, first pair is useless. If s starts with 0, index I 1 is useful because here the ones start from the first index and it is guaranteed that on the left it will have zeros. But what if it is starting with 1? Index 3 is to be considered. In this case, we can consider this index 2, sorry. We can consider this one because on its left and right we have zeros which will contribute with us additional 4 ones. So, yep, I think if S starts with 1, first pair is useless and second pair is of 0, it is of no use. And we start with index 2. If S starts with 0, we start with index 1. And we also do not want if last index is 1, block vector, we skip it. Because in this case you can see the last block is 1, it is of no use because of its right disability. Same in this case, no right 0, no right 0. So what we are doing is first initial count of 1, then store values in blocks, that is 0 1 0 1. There conti this one is like this continuous, what you can say, appears. And then with this rule we start if adding left and right block of zeros is greater than we store the maximum attained. Okay, so let's start. Pardon me because as of now the setup is not concrete, so there might be some issues. First we count initial ones, iterate Okay, we have found the number of initial ones. Now we want to keep a order of blocks. Suppose whether it is starting with 0 or 1, we definitely have a one occurrence of any of it. We have definitely one occurrence of any one. So we start from the next first index. If this one is equal to the previous one, what we do is counter plus plus that this block is still continuing. Else we need to create one vector. We push that blocks and counter will become 1 because currently the element at that index has one frequency. A single element can also form one block. Okay. Now if s of I double equals to 1, we, we start iteration with 3, 2 because first one will be useless and second 0 is else. Initially our answer will be the same as any count. What is it? Okay, number of ones. Because if we perform no operations, it will be same as original number. For I less than s dot not less, storer dot size. We do not want I plus equals to 2 because after this block of 1 it should be at 1 plus 3 after 2 index. So what will happen is if the number of zeros on its left plus number of zeros on its right plus number of original ones is greater than our answer will be the number of zeros on its left plus because first we convert that block to 0 and with the blocks on its left and right will convert that entire block to 1. We return answer. L. Okay, it should not be L but rather I minus 1, I plus 1, I minus 1, I plus 1. Okay, what is the issue? If s of I else Store dot push back. Hmm. Okay, we need to push back the final CTR because after iterating the entire array, the answer, the count of the last block will not be pushed as a result. We need to push it outside. Okay, so yep, this was the question. I hope you guys understood it. And yeah, if you have any doubt, do let me know. Let's talk about the time complexity. This is of n, and this is also of n. So the time complexity is of n. We are using an additional vector which is of n because what about suppose it was all alternating numbers like 0 1 0 1 0 1, the length of the store would also be the same as the original length of string, so it was of n and of n. Thank you.